The aim of this video is to give you some ideas about how you can process data and how you can plot it using a scatter plot. I have some resources here. The first resource that I have is this website, and this website can be used to create superscripts in Google Spreadsheet. And this tutorial is on Google Spreadsheet. Excel would be a little bit different. There's more you can do with Excel, but just because a lot of my students do have access to Google Spreadsheet, that's why I want to try to use this to help them with their assignments and their future as well. So this website over here can be used to generate superscript, and that's helpful because if you want to ever use an exponent, we don't want to be using let's say something is meters per second squared. This is not what we want to use when we're showing things, because this symbol, the hat symbol, is not the best way to represent things when we're writing them for reports. So instead, because this is in a denominator, we can write this as meters second. And for the exponent to the 2, so we can do one of two things. We can do meters per second, and we can just go to this website and generate a superscript for 2. I've just put all the numbers and letters in this thing over here, so I can just copy and paste it and we get meters per second squared, or we can just write it as meters per second to the negative 2, meters second to the negative 2 as well, and that would generate the same idea. So that's something that you can do. It's very useful. So that's one thing that I would recommend. Use this website. It's fantastic. And now these are the data. I'm trying to investigate the relationship between force and acceleration acting on a mass. And the data that I've collected, my raw data, I'm just going to call this raw data, include force and the final velocities. So I have an experiment in which I have a mass and I've put different forces on them for a period of 4 seconds. So I'm going to just write time is 4 seconds. Let's say error on my time is about 0.4 plus or minus. And so this is time, this is the error or uncertainty. And I've measured the final velocities for them, and these are the measured values that I've recorded. So let's start fixing the table first. So we can see that the force here has an uncertainty of 0.2, and that means my measuring tool has the ability to record things in 1 decimal place, and that would mean all of these values also need to be good to 1 decimal places. We can't have our uncertainty and our values have different number of decimal places. So I'm going to go here. In Google Spreadsheet, you can decrease decimal places or increase them using these two options. And sometimes if your screen is smaller, you might need to expand it a little bit, or there would be an arrow somewhere to bring these menus up. So if you press on this, everything has changed. Fantastic. You can see force is a vector unit, and it also has the uncertainty here. It has its unit and it has its direction. And this is exactly what we want. I have to also look at my velocity measurements, and it's the same idea. My uncertainty here was 0.5, and since this is written in 1 decimal places, all my measurement, that means my measuring tool could only measure up to 1 decimal place, and therefore all my measurements need to be the same. So I am going to move the decimals, and you got to be careful not to do it too much. In this case, I just need the 1. And now all my values are nicely laid out. And just to check final velocity, we got our uncertainty plus or minus 0.5. This is saying, this looks like it's milliseconds, and that's not the case. So you can either write this as meters per second using this, or you can use meters second to the negative 1. And I'm going to use my superscripts trick. I'm going to copy this, put it here, and I am going to copy the 1 and put it here, and now I have my meters per second, and my direction is forward. Note that the table looks pretty ugly at the moment. You can see that not everything is centered, so I want all my values to be centered. So I go here and I will do a horizontal alignment, and I make sure everything is in the center. You can also see vertically some of the values are vertically aligned in the center, but you can see that these are not and these are not, and it's looking a little bit weird. So I'm going to select everything, and I got a vertical align here. I'm going to click on it and go center, and it now looks absolutely beautiful. We can see my independent variable, we can see my dependence variable, we can see the trials. You can even highlight this if you want. You can right click, and or maybe you have to go to format and bold, or just press Ctrl and B and it will do it for you. Now that I have all my table properly laid out, let's start processing some data. I need to first of all find, I have calculated 3 measurements here just to make sure that I am reducing my random errors as much as possible. So I'm gonna have to find my force with my final velocity and the final velocity and its uncertainty. So I'm just gonna right click and copy this if there is that option. Yes, it is. And I'm gonna come here, right click, and you can paste or paste special, just the values only. I can just paste these because these contain no formulas, and in that sense I would have my uncertainties and everything in there. I'm going to need a new section here. I am going to merge these 2 cells by doing this, and I'm going to call this final average final velocity, and my unit here is going to be meters. I'll just copy it, actually, it's a lot easier. Meters per second forward, so meters per second, and direction is forward. And to do a better job here, you can wrap the text around here, or you can just press Alt Shift Enter, I believe. No, that's not it. It's usually Alt Enter. Okay, it didn't work the first time, but I'm gonna do it 3 times, and I'm just gonna make these cells a little bit bigger just so that everything fits. And fantastic. Okay, I get this. You can just do it in 1 cell as well. Actually, maybe I'll do that. Now I don't need this extra cell. So I'm actually just going to delete. I don't want to delete it. What I'll do is I will unmerge these cells here, and I will just move this down. I will move this down, and I will just make this cell a little bit bigger so we can see everything. Okay, I'm gonna highlight, and once I have this, I need the uncertainty of average velocity, and the unit for this would be in, I'm just gonna copy the plus and minus sign. That's also something I don't have the code for at the moment. This is going to be plus or minus meters per second squared again. So I'll just copy this, and I have it. Fantastic. I don't need a direction for uncertainty, but it's good to have my unit here. I'm just gonna highlight all this. Good. Move this a little bit in this direction. So let's find these first, and then we'll do the acceleration after. I'm just gonna highlight these as well and change the color to make it look a little bit nicer, and I'm gonna click these, go to borders, and have borders for them. I want to find the average velocity. Well, average is just taking the average of these values. So for 0, 0, 0, I'm just going to use a formula. I'm going to say equal. I'm going to type in average, open brackets, and I want the average between the three values here for 0, 0, 0. And I'm going to close brackets and press enter. And now it has calculated the average between these three values. I can pull this down, and as I do this, it will start calculating it for the next row, and so on all the way to the last row. So I've calculated my average and I'm ready to go. I'll center everything at the very end so that I don't have to do it multiple times. For uncertainty, I'm going to use this equation, the max value minus the min value divided by 2. Just to show you that it works in any way, I will do it for the bottom one and then drag it upwards. So I am going to use the equation. The equation is the max value. So I'm going to start with the brackets because I have to divide by 2 and everything in the numerator needs to be in brackets. In here, I'm going to use max value. I'm going to open brackets and say which I want the max value between these three. Close bracket. I'm going to subtract that by the minimum value of these three columns. Close them. And then I'm going to divide the result by 2. So here I'm taking the maximum value between these three, subtracting them by minimum value between these three, and then I'm taking all of that, the value, and dividing it by 2. Press enter. I'm going to take this, drag it upwards, and I have now found the uncertainty for all of these values. Easy enough. Now I need to find the acceleration and its uncertainty. So I am going to do this as acceleration. And the unit for acceleration is meters per second squared. So this is meters per second. And I need two things. I need the negative and I need the 2. So I'm just going to copy paste them. I'm copying using Control C and I'm pasting using Control V. So if you see me doing this fast, that's kind of what I'm doing. And this is the acceleration. The uncertainty is going to come in the next row, so I don't need to include it, but I do need a direction. So I'm going to say this is forward. So I will press Alt and Enter. And just to make sure everything is okay, I'll just put another Alt and Enter, and we have the acceleration. And we are going to also have the uncertainty. Of average acceleration, or just acceleration. We're assuming the acceleration is constant here. And the unit for this will be plus or minus meters per second squared. So I'm just going to copy this. And I'm going to copy the plus or minus sign. And leave a space between them. And close this. Good. So now I have all of these. I'm just going to color this in. I believe everything is colored. Yes, good. And I'm just going to make a border around here by going to the borders and go to all borders. And for acceleration, I'm going to be using this formula here. This formula is acceleration is equal to the final velocity minus initial velocity divided by change in time. My time is here, my uncertainty for time is here, and I am going to also include my initial velocity that was 0 with 0 uncertainty. For sure it was 0, I'm 100% sure. And for the acceleration then, I'm going to use the formula. So the formula is going to equal to the final velocity. So the final velocity for me was 0 here. Actually, because the top has, we're dividing by time, I need to use brackets here. So I'm going to use brackets, and I will do my final velocity, which is this value over here. I'm going to subtract it by my initial velocity. Since I'm going to drag this down later, when I choose my initial velocity and this number isn't changing, it's always 0, what you do to keep that constant is you put two dollar signs, one beside the G and one beside the 3. And you're going to close the brackets, and then you're going to divide it by the time. The time is also 4. When you drag things down, usually what happens is this box also drags down, so you don't want that. So you're going to click on it and put a dollar sign beside the G and the 2, and this will ensure that it's not, the box will never move to the right and will never move to the left. I'm putting a percentage sign instead for some reason. So now that I have this, this is good. This is saying subtract this value by this one, and then take all of that and divide it by the time, and that's the equation that I have for my acceleration. And it makes sense, acceleration in the beginning is 0. If you double click, it will do the job for you. It automatically notices that there are this many values, and it should work. Otherwise, you can just drag it or just double click here. For the uncertainty here, I'm going to use an equation we haven't covered in class, but I am going to take the percentage uncertainty of time, add it to the percentage uncertainty of my velocity, and multiply that by my acceleration. So this is going to be this value, and I need to make sure that that's not being dragged down, so I'm going to put a dollar sign divided by this one. I'm going to put some dollar signs on it, and I'm going to add this to the percentage uncertainty of my velocity, which is this one divided by this one, which will definitely give me an error. This one can be dragged down because we want to figure out the values as we go down. And then we are going to multiply this by our acceleration. And I need to also make sure that this is adding properly, so I need another set of brackets here. And this should do. This will definitely show an issue here, but for the rest of them, hopefully it will work. And it does. And I believe this is correct. And I'm just going to check and make sure that it's working. So it's the percentage uncertainty of orange over this. That's the uncertainty of time, plus the percentage uncertainty of my velocity. And then I'm multiplying all of that by the acceleration. Fantastic. And because this is, we know that it's 0, 0, 0, the uncertainty here is 0, so I'm just going to switch it to 0. And this would be realistic because the uncertainty here, if I'm not pushing it, it's not accelerating, and I'm 100% sure that there is 0 uncertainty in the acceleration of 0. So that's, the number there is good. In terms of decimal places here, well, we can see that when I have my average velocity and I divide it by time, the final answer should be good to 2 significant figures. And in terms of the uncertainty, it should kind of match with the decimal places. And just to be consistent, I know this one is going to be 3 decimal places, but for the most part, I'm going to keep it the same, and I'm going to leave all my answers in 1 decimal place. So I'm going to go right here and just change things and make sure everything is to 1 decimal place. In proper set of calculations, your uncertainty should only be good to 1 significant figure. So this should be 1, and this should be 6, this should be 2, this should be 8, and this should be 2, and this should be 10. But in this particular lab, we're okay. We're not going to use the rules that we would use in university yet. I just want to make sure you folks are completely okay with having the same number of decimal places for your uncertainty as acceleration. Later on, when you learn the rules a little bit better, you will see that these three values will be changed. Alright, I'm going to make sure that these ones also have same significant figures and decimal places, so everything is good now. I am going to make sure everything here has the same font and everything is bolded. I am going to make sure that everything is centered. It looks better now. I think the font here and here are different, so what we can do there is we can use this paint format, and that will change the format to how the other things are. And then I'm going to go back and just color this in. And I will format everything so that they're vertically and horizontally aligned. And this graph now looks fantastic. I can use it for representation. I can actually use it on my, I can copy this and paste it on my work. And if you ever find things that if it's not copying properly, then just take a screenshot and put it on your assessment. Just make sure when you're taking a screenshot that you're not clicking on one of the cells, because that could mean that it's also copying that, and it just looks weird. Make sure you click outside of that, take a screenshot and put it in, or again, if sometimes it copies things nicely, and just copy paste it. Okay, now that we have this, we're going to start plotting. To plot, I want to plot my acceleration and my force. So I am going to take my force and my acceleration, and okay, the way I'm clicking, I'm dragging this, I am holding control, the key control, and I think it's the same on Mac as it is on Windows, and you can select these as well. And once you have it, you're going to go to Insert, you are going to go to Charts, and you're going to get this lovely things. Column graph. In physics and in most sciences, we a lot of times we deal with scatter plots. So I'm going to go to Scatter Plots. And this is nice right now. You can see that this side has acceleration, this side has force. I don't need to include my uncertainty here, but especially since in Google Spreadsheet you can't actually show horizontal uncertainties, not that I know of. Maybe you can at some point, hopefully. But since I can't, it's not a bad idea to include it. You can see that you got force, you got the direction as well, and we're going to assume everything here is positive. Acceleration needs the units, so I am just going to go here. I'm going to just drag this down, and I will just copy this. I'm going to go down here. I'm going to double click. Oh, actually everything is already there. I think it's just not formatted really well, so I'm going to press back here, and I'm going to go back, and I'm going to press back again. Fantastic. I now have everything. I have the unit, I have the direction, and you can see it's meters per second squared. This is beautiful. This whole superscript, writing things as superscript really works, and it really works well. So here I have my unit and I have my direction. Title, I don't want a title. I'm just going to click on it and press delete because I will be labeling my graph and my labels. This would be like this would be, for example, figure 1, the relationship between acceleration and force. Just to be consistent here, I'm just going to make this acceleration capitalized, and things are looking good. I have my relationship here, and I'm going to click on these. It's up to you. You can keep these in, and some teachers like them. I think it clutters things a little bit, so I usually go to Guideline Color, and I'm not sure if you can see all of my screen. I am going to pause for a second. Sorry about that. I want to see, I want to make sure you can see all of my screen. So I have now added a little bit of that so you can kind of see what's happening on this side. I'm going to, when you double click, this comes up, this set of menus. And I'm just going to click on one of these sides. It doesn't really matter. And I personally like to keep it as no color. And I do the same thing on the other side, and I leave it as no color. It just looks a little bit cleaner that way for me anyways, but some teachers might prefer that you have all the major guidelines or some minor guidelines as well. Okay, I have these. Now for the dots themselves, blue is fine. I personally like red. Or I like red in these graphs. There's all the other nice colors that you can always choose as well. So just choose whatever you like. And when I click them, let's see what other option I have. I have options for error bars. I have options for data labels, and I have one for trend line. I need error bars and I need trend lines. I'm going to start with error bars. We have a few options here. We have none, we have constant, we have percentage, and we have standard deviation. I haven't used this before. I think it's a newer option, and I'm not sure how it's calculating them. So I'm just going to use a constant value. I am going to go and look at my acceleration uncertainties. And basically, if you're using Microsoft Excel, you have an option to choose these values properly. But in Google Spreadsheet, unfortunately, you don't have that option. So if I double click again and go to these, I am going to have a constant value, but I'm going to use my least value. So 0, 0.4, 0.6, 1.1, 1.5, and 1.6. And my smallest one is 1.6, and that's the one I'm going to use for all of them. Sorry, my largest uncertainty. So if you can't use, for example, 0 for the first one, 0.4 for the second one, and so on, then try using, just use your maximum value. That makes sure that it shows the maximum possible uncertainty in your graph. We can't, again, it doesn't seem like we can actually do, or can we do horizontal axis? Let's see. So in horizontal axis, we don't have, I don't see the option for, yeah, I don't see the option for error bars. We also want to add trend lines, so I'm going to add that trend line in there. And basically, based on my graph, you can see that a nice linear line is a great representation of my data. So I don't actually need to change it, but you may need to change it, and you can try different things here and see which one suits yours the best. I am also going to, just before try changing them, I will kind of show you different things that you can do here. You can change your line color. So if you want a different color, you can choose that. You can label. I am going to use equation, so I can see the equation of the line. And I will also have my r squared value shown as well. So here is my r squared value. I wish I could change the number of significant figures. I believe this will be 0.999 something, and it's rounded to 1, but that's okay. And the equation is there, and that's good. And I wonder if I can, what's custom? I think in terms of custom, you may be able to change some stuff as well. I just use the equation, and that's fine. And you can change the line thickness as well if you want to make it thicker. Your line of best fit, it doesn't really matter. This is fine, and this is fantastic. So now your graph has your vertical errors, it has the equation of the line, it has the r squared value, and it's got the I wonder if I can erase this, but I'm sure you can somehow. But all we really need is the equation here. If you have multiple things, and then it would show the different type of different equations of line of best fit, but in this case this is enough. And what else do we need here? I'm just going to show you if I chose exponential, it will try to fit in an exponential line. You can see that my r squared value is decreased if I do that. The r squared value kind of in layman's terms tells you how close are your points to line of best fit. In this case, you can see that some of them are close and some of them are not. And if that's the case, this value will not be as close to 1. It'll be closer to 0. So this is a good r squared value. The relationship is pretty strong. If I use polynomial, it kind of gives me a second order polynomial, which is also very close. It's r squared value of 1. Logarithmic, not as good, 0.94. Values closer to 1 are usually better. Power series, also great. But I'm going to go to linear because the linear looks fantastic for this set of data. Obviously, if I had more points, I would have a much better idea about how my graph will look like. If I only have 3 points, then my graph will look very strange. It could be straight, it could be this way, but the 6 points have helped me get a good idea about my relationship here, and it looks pretty linear, so I'm just going to go with the linear one over here. Alright, last few things. So it looks pretty good right now, but we can also just make it look a little bit cleaner. I'm just gonna click on this and I will bold it. You can see that you can title your formats here. It's pretty convenient. You can click on this, bold it, and now it looks fantastic. This is also pretty important information, so I'll bold that as well. And this is kind of telling me that my equation of the line is y is equal to mx plus b. So y here is my acceleration is equal to 2.03 times my force, which is my x, plus this value over here, which is very close to 0. So in this case, my relationship is pretty proportional because the line of best fit going through all the error bars is straight, and within the errors, it also goes through the origin. I hope that this video was helpful in giving you an idea about how you can process your data and how you can plot it so that you have your error bars, the equation of line of best fit, and your r squared value. Have a wonderful day.